All right, this is part 2 of the practice test. I didn't realize how long it would take me to go through and explain the first 10 questions, so I figured I'd split the videos up. So for question number 11, it says circle O is given below. A, B, and CD intersect at point E, which is not drawn, so let's go ahead and draw that. If the measure of arc AD to measure of arc AC to measure of arc DB to measure of arc CB is given by the ratio 3 to 2 to 2 to 1. What is the measure of AED? So AED is the angle in question. That's what I want to find out. Let's get our X value first. Remember with the ratios, we want to put an X by them all and put them on the right spot. So AD is going to be up at the top. AC and DB are both 2. So 2x and 2x, and CB is going to be 1x. So we're going to start by doing 3x plus 2x plus 2x plus 1x. Their sum is 360 degrees. So that's 3, 4, 5, 6, 7, 8x equals 360. And divide 360 by 8, and you're going to get 45. So if I go through and I plug 45 in, that's going to be 45 degrees here. Twice 45 is 90. So 90 degrees, 90 degrees. And 3 times 45, what's that equal to? That's going to be 135. So you can get all your arcs, 90, 45, 90, 135. Now to get the measure of angle AED, AED is an interior angle and it's not in the center. So it's not equal to the angles, but it is the average of the two angles that it intercepts. So if you look at these intersecting lines, it's the average of the two, I said angles, the two arcs that it intercepts are the ones at the top and the bottom, the 135 and the 45. So to get that angle, I'm going to use the formula 1/2 angle equals 1/2 arc plus arc. I'm going to plug in the 1/2 and the 135 and the 45. And those add to 180. And 180 divided by 2 is 90 degrees. So this is going to end up being a right angle on this specific problem. So the measure of angle AED is 90 degrees, which obviously is not drawn to scale. So don't look at it and say, oh, that looks like it's 100. It's 90. Go by what you have to solve. Okay, let's look at number 12. All right, in the figure below, PR and SR are tangent to circle O. Tangent means that they hit the circle once. They do not go inside the circle. And they're supposed to make a right angle with the radius that's drawn toward the point where it hits the circle. Obviously, that's a little bit off, but you can make a right angle for both of those. All right, the information given to us, OT is 6 centimeters. So that's going to be 6 along here. And PR is 8 centimeters, that's over here. What is the length of TR? Well, I'm first going to realize that because OT is a radius, any radius is going to be the same length. So that's going to be 6. And in a right triangle, if I just kind of pop this one out for a second, I can get OR by doing a squared plus b squared equals c squared. Because that's just a right triangle. I'm trying to solve for the hypotenuse. So that's 36 plus 64. And that's going to be 100 equals c squared. So the square root of 100 is c, that's equal to 10. Okay, so now if I want to find TR, so T is somewhere over here, and I know this section of it's 6, well then TR is going to have to be the difference of 10 and 6. So TR is going to be 10 minus 6. which is going to be 4. So since our unit's in centimeters, that would be 4 centimeters. Okay, so the segment on the bottom part, this is a tangent and an outside part and a whole part. And the whole part would be 9 plus x. So remember, the formula is tangent squared equals outer times the whole. So the tangent's 15. The outside is 9. The whole thing is the sum of these, so 9 plus x. All right, 15 squared is 225. And I'm going to have to distribute that 9, so that's going to be 81 plus 9x. All right, 225 minus 81. 144 equals 9x. X is going to be 16. So that's a kind of a more basic problem, just plugging in the formula. Okay, question number 14. All right, this problem is once again one of those segment formulas. On this problem, remember I just do A times B equals C times D. So what's important is that if they're along the same segment, they get multiplied together. So you don't want to do A times D, you want to do A times B, which means that I'm doing this times this. And I'm going to set that equal to those two multiplied together. So I'm going to have to distribute the 8, so that's going to be 32x plus 16. And then 9 times 4x is 36x. So I will subtract the 32x from both sides to give me 16 equals 4x. And 16 divided by 4 is going to be 4. So that's another problem where you just plug it in the formula. Make sure you distribute on that one. All right, question number 15. It says AB is the diameter and K is the center of the circle. The measure of angle CAB is 37 degrees. So that's going to be over here. What is the measure of angle AKC? Well, we have to add that angle. That's not drawn. So AKC is this angle. And that's a radius that I just drew, which means it's going to be the same length as KA. So I have an isosceles triangle. Therefore, the angle of the KCA is going to also be 37 degrees. So if I want to know this angle, I'm going to take those two 37s away from 180. That's going to give you 106. Okay, question 16. You have what we call a cyclic quadrilateral. In a cyclic quadrilateral, remember that the opposite angles are supplementary. So opposite angles are supplementary, which means the measure of angle A plus the measure of angle C is equal to 180. So 4x plus 12 and 100 equals 180. And the measure of angle B plus the measure of angle D also equals 180. So 6y plus 10 plus 130 equals 180. So if we solve those, we're going to get 4x plus 112. And ran out of room here, so let's subtract the 112 and divide by 4. And we'll use our calculator. 180 minus 112 is 68. Divided by 4, you're going to get x equals 17. Okay, so for y, you're going to do 6y plus 140 equals 180. And let's go ahead and solve that out. 180 minus 140 is 40. And divide by 6, and you'll get about 6.67. So to answer the question, what is the value of x minus y? Well, x minus y will be 17 minus 6.67, which is going to get us approximately 10.33, and that's going to be repeating. So 10.3 repeating is fine to write, or about 10 1/3. Okay, so question 17. Okay, we are asked to, let's see, we have BD is a tangent to the small circle. So we got a tangent here. The radius of the small circle is 7. What we want to do is we want to draw our radius straight up, because that's going to make a right angle and cut that in half. So we're going to write a 7 here. The radius of the large circle is 12. That's the center of the circle to one of the points. We can go to D or B. That length is 12. What is the length of BD? Well, BD is twice the length of that segment. So we're going to use the Pythagorean Theorem to solve for that segment. We'll call it x. So we'll say 7 squared plus x squared equals 12 squared. Remember, this is your hypotenuse, so that's going to be your C. So that's 49 plus x squared equals 144. And 144 minus 49 is going to get you what? 95. So x is the square root of 95. And the square root of 95 is 9.7467, so approximately 9.75. Now, if I look at that number, and I got to realize that BD is twice as long, so BD is going to be 2 times x, so it's going to be twice times 9.75, which is about 19 and a half, so 19.5. Okay, question number 18. A stainless steel circle with a circumference of 400 is forged. Let's circle that. Circumference is 400. A 14 centimeter arc of this circle is cut out. What is that? 14 centimeter arc. Centimeter is a length. So that's a length. That's my arc length. What is the measure of the arc in degrees? Degree of the central angle. So let's look at how we set up that formula. The formula for arc length is circumference, which is 2 pi r, times degree over 360. Well, since I'm given my circumference, I'm going to go ahead and substitute 400 for that. And I'm going to substitute 14 for L. So that's going to be 14 equals 400. My degree is unknown, so let's call that x out of 360. So to solve this for x, you're going to multiply by 360 and divide by 400. So times by 360. .360 times 14 is 5040. And divide by 400. And that'll get you a degree. So 5040 divided by 400 is 12.6. So that arc's tiny. It's 12.6 degrees. Okay, question number 19. In the diagram, the inscribed angle ABC has a measure of 50 degrees. So inscribed angle is ABC. That's 50. Arc or segment AB and segment BC are congruent, so those are marked equal, which means those arcs are equal. And the radius of the circle is 18 units. So we know the R is 18. So 18 right there. What's the length of arc AB? Again, another length formula. So 2 pi r times degree over 360. The key on this one is, we got the radius. We got to make sure we have the correct angle. So there's a couple ways to get that angle. I find it easiest to use the inscribed angle and double that. So that's going to be 50 times 2, which is 100. And since I know these are going to be the same, I can subtract 100 from 360. And these two add to 360. So this is going to be 260 divided by 2, which is 130. And that's going to be 130 as well. So 130 plus 130 is 260 plus 100 is 360. So I want to know, what is the arc length of AB? That 130 is the central angle, because remember, the arc and the central angle are congruent. So I'm going to use 130 for my degree. My R is 18. And let's plug that into the calculator and we'll get our length. So the arc length for AB is about 40.84, and the units are missing, so we'll do that. So AB is going to be about 40.84 units. All right, our last problem on the practice test is going to be question 20. It says, in the diagram, CB contains the center of this circle. All right, remember the center of the circle, chord that goes to the center of the circle is the diameter. So right off the bat, we know that's the diameter. What we have is the measure of angle ACB again. We have another inscribed angle. So ACB is 40 degrees. Arc AC is 12 pi units. So arc AC is 12 pi units. Well, what is that? That is our length. AC has an arc length of 12 pi units. What is the length of CB? That's again a diameter. So if we get the radius, we can multiply that by 2 to get the diameter. Well, once again, we have to get that, we got to get the angle represented here. Now, there's a couple ways to do it. You can say, oh, I just made an isosceles triangle and bring a 40 over here. 40 plus 40 is 80, and 180 minus 80 is 100. You could also take that 40 and times it by 2, which is 80. And if you realize that's half a circle, well, then this is going to be 180 minus 80. And so that arc's going to be 100, therefore the central angle is going to be 100. Whatever the case, your degree is going to be 100, okay? So if I want to know the length of CB, if I'm given the arc length, I'm going to use the arc length formula once again, which is 2 pi r times the degree of the central angle over 360. I'm going to plug in the arc length, which is 12 pi. And I'm going to plug in the 100 for my degree. I cancel out where I can, so I'll cancel out those pi's. So I'm going to have 12 equals 2r times 100 divided by 360. I guess I can put that all over as one fraction. Regardless, I want to multiply the 360, divide the 2, divide the 100 to get the radius. So you can do all that in as many steps or as little steps as you want, okay? I tend to just combine it all at once. So do 12 times 360 divided by 2 divided by 100. So my radius is 21.6. So how do I get CB? Since CB is the diameter, that's going to be twice the radius. So the radius is 21.6. The whole length of CB is going to be 43.2 units. And that concludes the practice test. Man, I hope that was helpful for you. And study, look over those formulas especially. You got to know how to get those angle formulas in a circle. So that's all I got. See you tomorrow.